This week we're continuing to look at triangles and how they work alongside the sine and cos and things like that. So our title for today is going to be the sine rule. Now you'll notice there's an E on the end of sine in the sine rule. It's worth noting, I think, at this point that the button on the calculator that looks like sin, we say sine, that sine word is short for sine with an E on the end. So on the calculator, sine is short for sine and cos is short for cosine. That's really important. Next lesson we're going to be looking at the cosine rule. So like the cos rule, and then I guess it's just for interest's sake, tan stands for tangent. Nothing really to do with tangents that we've looked at before, it's just what it stands for. So last time when we were looking at area of triangles, I said that we had to label our triangle in a really specific way. And I said that labelling system would come in useful again. And today's the day. So let's draw ourselves a triangle. So these rules allow us to do things with triangles which aren't right angled. So trigonometry, the SOHCAHTOA, that allows us to find missing sides and missing angles, but it has to be a right angled triangle to start with. It's a bit of a pain. Most triangles that we deal with in maths aren't right angled, so that's when the sine rule and the cosine rule come into play. They allow us to find sides and angles with only a little bit of information and in a triangle that isn't right angled. So, see if you can remember how we labelled this triangle last time. We used lowercase a, b and c and uppercase a, b and c. So just like Pythagoras, remember, the little a, b, c are the sides, and it doesn't matter which one's which. And then remember, it's exceptionally important that your big A, your angle A, is opposite your side A. And your angle B is opposite your side B. And your angle C is opposite your side C. It doesn't matter where I put the A, B and C on the sides originally. What does matter is that my C is opposite my C, my B opposite my B, and my A opposite my A. So last time we looked at the area and we said that you could work out the area by doing a half AB sine C. So remember, we can only do cos, sine and tan of an angle. So half AB sine C, and we said that A and B made angle C. So when we labelled our triangles, we labelled them such that A and B made angle C. Well, today we're using exactly the same labelling system, and we're looking at something called the sine rule. Now this allows us to find sides and angles if we're missing a little bit of information. And the sine rule, there's actually two forms. So I'll write both, and what you'll see is one is just the other one kind of flipped upside down. Perhaps we'd say the reciprocal of the other one. But I'll write them both down. So I've got A over sine A equals B over sine B equals C over sine C. So that's what we call the sine rule. Our side A divided by the sine of the angle A, that's got to equal the side B over sine of the angle B, and that also equals the side C divided by the sine of the angle C. This is also true the other way up. So sine A over A equals sine B over B, which equals sine C over C. And you'll choose which one to use based on what you're trying to find. If I'm trying to find a side, this top one is probably more useful because the sides are on the top. If I'm trying to find an angle, the bottom one is probably more useful. So this one's for trying to find a side. just because it's on the top. You know, in algebra, when I say it's a bit of a pain having an x on the bottom, well, here we're in the really lucky position where we can choose not to have our x on the bottom. But I only ever learnt one when I was at school. I learnt this top one when I was at school, and I just used that one all the time. It requires a little bit more rearranging, but I found that it was less to remember, and the fewer things I had to remember, the more chance there was of me remembering them. So that's how I'm trying to find a side. And this one is probably then going to be trying to find an angle. It just stops you having kind of your x on the bottom, as it were. Right, so let's see how this works in practice. I think it's really, really important to say that in practice, you will only ever use kind of 2/3 of the equation. So you'll only ever use that bit, or that bit, or that a over sine A equals c over sine C. We don't often have equations or use equations in maths that have two equal signs. So you'll see what I mean once I've labelled my triangle. We're only going to need 2 of these sections. That's going to be enough for us to be able to work out what we're trying to work out. So let's draw a triangle, label it, and see what I'm waffling about. Just draw a random triangle. It doesn't matter at all. Right, so I'm going to say that that is 83 degrees. I'm going to say that that is 41 degrees. And I'm going to say that that is 18 metres. And I'm trying to find that. Oh, sorry. Like that. So I've got an 83 opposite an 18. I've got a 41 degrees opposite an x. So x is what I'm trying to find. Before you do anything at all, you need to get that triangle labelled. And it doesn't matter at all where anything goes. So I'm going to call him little a, which makes him big A. I'll call him little b, which makes him big B. And then that one would be C and little c. Right, look at what you've got now. We're going to decide which letter we don't know anything about and we don't need to know anything about. So these C's, look, I don't know anything about him and I don't want to know anything. And I don't know anything about him and I don't want to know anything. It's like trigonometry when you decide whether you're using SOHCAHTOA or TOA, yeah, from SOHCAHTOA. So I'm getting rid of them. I don't need or want to know anything about the C's. So from my equation, I'm only going to be using the bit with the A and the B. That's going to be enough. Just having one equal sign is definitely going to be enough. Our normal equations only have one equal sign. So we just pick the bit that's going to help us. So we want the bits with A's and B's. Now, are we trying to find a side or an angle? Well, look here. X is a side. So we're trying to find a side, so we're going to use this. So I'm going to write A over sine A equals B over sine B. I don't need to write equals C over sine C because that's not going to give us any information whatsoever. Right, now I'm going to substitute in. So little a is 18, and then I've got sine of big A, and big A is 83. So I've got sine of 83, and that's going to equal my little b, which is x, over sine, and what's big B? 41. Remember, we do sines of angles like that. And we're trying to find x. So think about what I would say, kind of the story of the x. So what's happening to the x at the minute? Well, the x, look, is being divided by sine 41. That's what's happening to the x at the minute. It's being divided by sine 41. Hence, in order to get the x by itself, I need to multiply both sides by sine 41. So I'm going to have 18 over sine 83 times sine 41. And that's going to leave me with the x all by itself, isn't it? If I had an x over 3, you would know that you needed to times by 3 to get the x by itself. Okay? Right, now get your calculator and make sure you've got a capital D make sure you've got a capital D at the top here. If you haven't, get your instruction booklet out and make yourself have a capital D at the top. I think it's quite simple. I think you press Shift, Setup, and then press 3, and that will give you degrees. You've probably got an R. If you haven't got a D, you've probably got an R. R is just another way of measuring angles, a bit like degrees. But anyway, press 3, and that will put you a D at the top. Right, and then type in exactly what we've got. So I've got 18 over sine 83 times sine 41. So that's what my calculator looks like. And then press equals, and that tells me then that 11.9, I'll round it to one decimal place, 11.9 is x. Now don't forget our units. So that was in meters, wasn't it? So 11.9 meters is x. So that's not too difficult, just providing you've labelled your triangle correctly. So that's one example where we're trying to find the side. Let's look at one when I'm trying to find the angle. You'll see that it's exactly the same. It's nothing to worry about. So again, just draw me a triangle. I'm trying to draw them different every time, and they're either coming out isosceles or right-angled. And we've got what looks like an equilateral now. Never mind. Right, so this is what I'm trying to find. I'm going to call it theta. You can call it x if you want. I'm just going to we often use theta for angles at A level, so you may as well start now. So that's a theta. It's a Greek letter. It's kind of like a 0, and then you go through and you cross it. Put an x if you want. And let's say that this is 62 degrees. And let's say that this is 15 centimetres, and this is 11 centimetres. And this is, oh, that's all I need, isn't it? Let's stop there. Quit while I'm ahead. So, step 1, before you even really registered what on earth's going on, let's label our triangle. So, little a, that was random. Doesn't matter what you do, but now it's not random. My big A has got to go opposite my little a. So A, big A opposite it. I'm going to put a little b there and a b there, and a little c there and a c there. You might have a different labelling system to me, doesn't matter. Right, now we do the what have I got and what don't I care about analysis. So look here, this B doesn't have anything with it, and I don't actually want to know anything. And this B here doesn't have anything with it, and I also don't want to know anything about it. So those B's can go. So look, I've got A's and C's left. So I'm going to be using A and sine A and C and sine C. And then think, what letters have I got here? Well, I've got A's and C's, and what am I trying to find? I'm trying to find an angle. So I'm going to want the angly stuff on the top of the fractions, just to make my life a little bit easier. So I've got A's and C's. So I'm going to have sine A, big A, over little a, equals sine big C over little c. Okay, you might have labelled your triangle in such a way that you're interested in A's and B's, or B's and C's. So your equation would reflect that. So now let's stick in what we know. So what's my A? 62. So sine 62 over, and what's my little a? 11. And that equals, what's my C? It's a theta. Sine theta over, what's my little c? 15. Okay, so now my theta-y thing, my x-y thing, my unknown variable is on the top, which is always nice in an equation. So it's on the top. And what's happening to it? Well, at the minute, it's being divided by 15. So we know what to do. We know that we're going to have to times both sides by 15. Right. If I type that into the calculator, that would tell me what sine of theta equals. Well, I don't want to know sine of theta. I want to know theta. And we know from doing SOHCAHTOA how we get rid of a sine. Remember, we have to do what we call an inverse sine. On the calculator, you press shift sine, and it gives you a sine with a little -1. That's what we call an inverse sine. So I press shift and then sine. that gets rid of the sine on this side, but because it's an equation, I'd have to do the same to both sides. So on this side, I would do inverse sine, and I'm going to have to do inverse sine of everything. And on this side, when I do an inverse sine of a sine, it just goes. Like doing a square root of a squared. Yeah, they're the inverse operations of each other. So that's how I end up with theta by himself. So if I type this in now, so I've got sine 62 over 11 times 15, and all of that, look, is in my inverse sine, and I get a maths error. So this triangle that I've just come up with must be impossible. So that's quite interesting. So, well done me. This is the kind of thing I'd do at the whiteboard, isn't it? So, this triangle mustn't be possible. That's what that maths is telling us. So let's go back through. I think we need to make this longer. So can you, I'm really sorry, can you go back through and change your 11 into a 21? All the maths that we've done is right. I just made a mistake with the original triangle. Like that. Okay, so everything, all the maths that we've done, everything I've said is correct, apart from the fact that that triangle that I've drawn isn't actually possible. So let's type this in. So inverse sine of sine 62 over 21 times 15. So I get 39.1 degrees is theta. Okay? So that wasn't as smooth as it could have been, was it? Never mind, it's like my lessons, there's always a hitch, isn't there? So, we've done two examples. One is where we find the side, which arguably is easier because I don't have any inverse sining involved. And then the other one, exactly the same situation, apart from our unknown is trapped in a sine, so we need to do the inverse sine to get rid of it. So your workings will either look just like that, or they'll look just like that. Okay, now this looks really complicated, but that's okay. Now at this point, you might have written it out a little bit differently. So you might have worked out what the left-hand side equals. So you might have worked out sine 62 over 21 times 15. So you might have written 0.631 equals sine of theta. All I've done is change this left-hand side for a decimal, and then inverse sine of that equals theta inverse sine of my answer, 39.1. It doesn't matter actually which method you use. This is possibly a bit quicker, and also it means there's no chance for any rounding errors. So I would recommend this method. This method I think looks a bit less scary. So I'll leave it up to you. So I'd like you to have a go now at worksheet 1. As always, please get in touch. If there's anything I can do to help, if you want me to go through another example, if you want me to do anything at all to help, please let me know. So yeah, I'd like you to have a go now at worksheet 1. So write some notes from this video and then have a go at worksheet 1 and get in touch with any problems. I hope I can see you very, very soon. Bye.